Thank you very much. Hi everyone. So I would like to talk a bit about the research we are doing at Zermod and also the development projects. First, rapid introduction about myself. I've done my studies in France, in Bordeaux. I've studied programming language design and software architectures, software engineering, stuff like that. And currently I'm associate professor at University of Lille. I'm co-author of this book, the third one being Enterprise Pharo Web Perspective. It's not released yet, but we expect it before the end of the year. So I would like to start by presenting my research team. So it's called ERMOD. It's led by Stéphane Ducasse. We are 6 permanent researchers. We have PhD students. We have interns. We have postdocs. And if you are a student interested in an internship, then you might want to contact us. There are people coming from all over the world in our team, and mainly from Argentina. So if you are Argentinian and join us, you won't be disappointed. So there is plenty of mate and alfajores, and so no problem. The objectives of our research team are threefold. So the first one is re-engineering. So we would try to help developers understand and maintain their software, and in particular large software. The second objective is to help software evolution and isolation through programming language constructs. So we work mainly in the context of Pharo, and we try to improve Pharo to help developers in this perspective. And the third one, thank you very much. And the third one is the ecosystem around Pharo. So we put a lot of effort in engineering Pharo and its libraries and virtual machine and all the ecosystem, and we created an association, a consortium. So those are the three objectives of the research team. The research team is separated into 2 parts. The first part is the re-engineering part, I told you, and the second one is the languages and IDE. Each part of the team builds its own platform. So one platform is Moose, and the second platform is Pharo. Those platforms are open source and free, and we did them so that everyone can use them. And Moose is implemented on top of Pharo. They are available for free, and many people use them worldwide. So we have a lot of universities, companies, research groups that use Pharo for their own stuff. And they contribute back to Pharo. So we really encourage contribution from everybody, so that Pharo and Moose really improves based on these contributions. There are many contributors. And then from these contributions, the research team can improve its research. We really leverage people using our frameworks and platforms. For example, when we invent something and want to try that, we ask the community to try it, and we evaluate the impact of what we created based on the user feedback. So it's really important for us to have this loop. So we help people by providing platforms, and they help us for our research. The re-engineering part of the team goal is to study and help developers maintain large software systems. One of them being Pharo. The re-engineering team work on Pharo. So this is one of the use cases that they have. So they frequently create such kind of visualizations where we see that help the Pharo developers maintain the system. I will present this visualization a bit later. And they produce other nice visualization. And these help us understand, this help the Pharo development team understand Pharo. But it's also in the opposite. So the language and IDE part of the team, they create language constructs that are used in Moose, so that we can see that our constructs can be really helpful in the real world. So I showed that just to tell you that there is really a synergy in R mode and in the platform. So everybody uses everyone's work. But so this is the main overview of my talk. First, I will talk about research and a few research projects, and then a development part. So I would like to start by talking about moldable tools. The idea here is that developers create higher and higher abstractions. So they create libraries, they create frameworks, they create domain-specific languages. The problem is that our tools, typically, they only show things that are very low level. So this is true of Pharo Smalltalk. This was true of Pharo Smalltalk, but this is also true of Eclipse, for example, and other Java IDEs. So let me show an example. Here you have a typical relationship between two classes. So you have a contact book and a list of contacts. And we would like to inspect a contact book just to see what's inside. So typically you would see something like that. So this is a view in Pharo, but in Eclipse it would be exactly the same. So what we have here, we have the object representing the contact book itself and the value of the instance variable contacts. So here we see that the contact is an ordered collection of 5 items. If I press here to have some details about the contact book itself, so its contacts, I see that the ordered collection is indeed an array with the first index and the last index. But it doesn't give me any information about the contact book. So you have to press the arrow again to unfold and to see that, in fact, I have 5 contacts with an email address and a few nil objects I don't care about. So here we see that the default tools show a very basic view of my objects. And typically, as a developer, this is not what I'm interested in. I would like a higher view of my objects. So one-shot view could be this one. So when I inspect a contact book, I would like to see the list of the contacts in this contact book with their name, email address, and maybe a picture. As a developer, this is what I would like to see. And typically, the tools don't show me that. To encourage developers to create views like that, there must be tools that let developers do that simply. So it should not take 2 days to create such a visualization. So this project aims to create tools that makes that very easy. And here we have an example. So this code here, these few lines build the view on top. So as you can see, there is nothing very complex. So we define a method. Here there is a pragma so that the tool can find the visualization. And here we say that we want a table. The title should be contacts. This is what appears in the tab above. And then we would like to display the result of sending contacts to self. So we get the list of all the contacts. And then we want 3 columns, the name, the email, and the photo. And the result of this column is by sending the message name to a contact, the message email to a contact, and the message gravatar as form to a contact. This should not be more complex than that. So here are a few examples of objects that might benefit from such a view. So for example, directories. When I inspect the directories, typically I don't care about the inode, that's operating system specific information. What I care about is the content of the directory, the number of files, and the dates, stuff like that. The same for the files. If I inspect a metric, which is a number and a unit, I'm interested maybe in having the same value in multiple compatible units. If I inspect a method, I'm interested in seeing its source code, its abstract syntax tree, its bytecodes, stuff like that. So let me show you an example.
see the name.
Okay, yeah, wait.
Okay, just let me know.
If I'm not talking, then it's okay.
Okay.
Come on. Yes. Is it better now? So imagine I want to inspect the color red. What I want to see is the color, right? I don't care about the value of R, G, B, and stuff like that. If I'm interested, I still have the values here. But typically I don't care. And if I send the message much lighter to get a lighter red, I'm still interested in the value, in how it looks like. So here I can see how it looks like. So on the right, we see an inspector on the result of evaluating this expression here. So on the right, we see the color that results in sending much lighter to red. So that's very easy. So if I inspect a directory, what I want to see is the directories and the files inside. If I'm interested into the details of how this is implemented, I have the information, but typically I don't care. So I want to see the directories. And if I click on one of the files in these directories, and then I see the contents. Last example, I'm inspecting a method. So when I'm inspecting a method, I might be interested into the bytecodes. I might be interested into the source code, and I might be interested into the AST. And if I care about the AST, I can inspect the AST itself. So here, I'm clicking here, so I see a view of the node I selected. So here I see a view of the RD method node. If I click on variable nodes, then I see that a block is selected. I see that what is selected on the left is also shown on the right. So I can see that there is a mapping between the source code and the abstract syntax tree. So I can understand my abstract syntax tree by navigating here. So this view that I already shown presents something very interesting. So here, each circle that you have in gray represents a class, and when the class, when the circle is red, it means that there is a special view for this particular class. So here we see that already many classes of the system have at least one special view, and some have many, like the method. Has at least 3 special views. Yeah. So this view really helped the development team of Faro to understand where efforts of creating new views should be put. Do you have any questions about these small table tools? Yeah, feel free to interrupt me at any time because I will talk about very different topics. Yeah. The pragma that we see here is useful because the method is added to the class representing the object you want to inspect. So this method is implemented in the class contact book because this is where I will be able to send things like to objects. This is where I will be able to have all the information about the object I want to inspect. So the pragma here is used by the general inspector window to decide which tab to create. Another question?
Yes.
Yeah.
Is this method representative of the effort the parameter has to put to have a specialized view?
Yeah, so the question is this method representative of the effort? Yes. I didn't pick a simple example just to show you. This would be very, very simple. So I don't remember the statistic, but Tudor, Girba presented some, and they were very, very small. So each method is very small. Yeah. So this is really the goal of the project, is to encourage developers to create their own views. Yeah. Sorry, I can't hear you. Yeah, in fact, so yes, there is a learning curve. You have to know the API, but as you can see, this is nothing really magic, and yeah, and there are already plenty, as I showed you in the figure. So you can learn from the examples. Any other question? Yeah.
So let me know if I got this right. So isn't that you'll have to implement this message on the instance side of the class?
Indeed. Yeah, on the instance side, yes.
Is there a reason you decide to go that way, that coupling the model with these inspectors instead of doing maybe the other way around?
So the question is where this method is better placed. Is it on the model or in the view? Both could work. I agree. Here the idea is that you typically package this kinds of methods in a separate package. So this is an extension method to the class. So if you don't need the view, you don't deploy it. But I think it makes sense that when you browse a class, you also immediately see all the possible ways to view it. But I agree that it could be done differently, and there are probably pros and cons of both solutions. Yeah. Okay. Let's go to the next topic, first class relationships. So it might be that sometimes you need some complex relationships between objects. So here we would like to express the fact that a boss has from 2 to a lot of employees, and an employee has 0 or 1 boss. If you try to implement, to write code to model that, you have a lot of things to do. You have instance variables on both sides that you have to define. There is an initialization code that you have to write. You have to implement boundary checks. So if you remove a boss from, if you change the boss of one of the employee, you have to make sure that the previous boss still has at least 2 employees, stuff like that. And you have to synchronize when you change one side of the relationship. You have to also change the other one. And there are also many actions methods that you have to implement, like add employee, remove employee, set boss, stuff like that. We believe that this is too much work, and this is error prone. So what we would like to do instead is to specify in a way this relationship just like that. Maybe not with a line, but with very simple smalltalk code, and that the rest should be automatically generated. So we have only started having a look at that, and we currently search for use cases of these relationships a bit complex. So yeah, this is just starting, so I won't go further in that. One work that is much more advanced is the first class IDE events. So this is Epicera, if you have heard about the project name. This is done by Martin Diaz, a PhD student in our team in Argentina. One more. So the idea here is that you are a software developer and you work. You have to implement a feature. So what you do, you add a method to your project, and then at some point you realize that, there is a bug. Too bad. So I need to fix the bug. You modify a method, and then you modify the method again, and then you see that the bug is fixed. Now you go back to your feature, and you add a class, and you modify a method, and you do a lot of things to finish your feature. When you're done with the feature, what you want to do is to share. So you want to share your work with the other developers through a repository. So typically you would use version control systems and you would commit your work. But there is a problem here. The problem is that if you commit just like that, you are going to mix several activities inside one commit. You are going to put a bug fix and a new feature inside the same commit. And this has a lot of problems. We call that a tangled commit or a non-atomic commit. So why is that bad? It's bad because it makes review and integration harder. So as a reviewer of the commits, you will have to understand both the new feature and the bug fix to decide if you want to integrate or not. This also makes the reversion harder. So 1 week later, after integration, you would like to revert the feature addition because you see that there are a lot of problems, or you want to keep that for the next release, but you would like to keep the bug fix. This is difficult because everything is mixed. And this also makes historical analysis harder. So when you go back in time and you want to understand what happens, you see when commit contains multiple things, then it's harder to understand. So, best practices create untangled commits, also called atomic commits. So this is a very well-known knowledge that all developers should commit things atomically. So one activity for one commit, and you don't mix activities inside the same commit. So the problem with that is that this is difficult and this is error-prone. So you might create, you might mix things inside one commit. So what do we need here? We need a tool. We need a tool that from a tangled commit will separate the several changes into the different activity commits. So one commit for the bug fix and one commit for the feature addition. And you're very lucky because we did that. We created a tool that from a bunch of changes, of random changes, will separate the changes into separate commits and commit things independently. So rapidly, how does the tool work? The tool works by first taking each pair of change separately. So change 1 with change 2, change 1 with change 3, change 1 with change 4. So all possible pairs. And then we compute a lot of metrics. So each yellow square is a different metric for each pair of change. And at the end, when we have all the metrics, we use a machine learning algorithm to decide which pair of commits should go, which pair of change should go in the same commits, and which pair of change should be separated in different commits. So what are the metrics that we use on the criteria? So the first one is called order distance. So the idea is that we count the distance between two changes. So between 1 and 3 there is 2. Between 2 and 3 there is just 1. And between 4 and 5 there is 1. So we count the distance between all the changes. If there have been many changes between two changes, the idea is that these two changes should probably go in separate commits, because typically the developer is focused on one thing. And then the second column shows the time difference. So here it says that between change 1 and change 3, there was 300 seconds. Again, the idea is that if there is a lot of time between two changes, so it's probably that the developer switched to another activity. And we have the same test run. It's another criteria. So the idea here is that if you have a red test followed by a green test results, then probably what's in between should go together. So none of these criteria is exact. So there are plenty of examples where one criteria would not suffice to decide, or would even say something wrong. That's why we have plenty. So here I only show 3, but there are many, many, many. So for example, one other could be if 2 changes touches the same method, then maybe they should go together. If 2 changes changes the same class, maybe they should go together. So there are plenty. And from all these values, we give everything to machine learning algorithm that will give a probability that the 2 changes should go together. So maybe 1 and 2 are 90%. We are 90% sure that they should go in the same commit, and maybe for change 1 and 3, we are 50% sure that they should go together. With all these probabilities and some thresholds, we will try to put the changes in separated commits. We have studied developers during many months. We gathered all the data, and at the end the tool provides the clusters. So all these changes together, all these changes together, all these changes together. The developer can drag and drop from some changes before committing, so that if the algorithm does something wrong, then the developer still is in control and can have an impact. And at the end, the developer press commits, and all the commits are done separately. So here it's important to note, and maybe it was clearer in the previous slide. It's important to note that here we don't have line-based changes. We don't care that one line has been removed, one line has been added. This is typically what you would have with version control system. In our approach, we care about the high-level changes, the semantic changes. We care about the fact that the method has been modified, and we care about all the modifications that have happened to the methods. So if a method is saved 3 times, here in the history, you will see 3 lines showing the events. Why do we do that? Because we believe that sometimes a method can be modified for multiple reasons. So you might modify a method to fix a bug, and later you modify it again to add a feature. If you only look at the end result and the patch between the previous version and the new version, then you will lose all this information. Our tool works really well, and this is because we have all this information. So we also record unit test results while the developer works, and we also record all the refactorings because we believe all this information can be important for the tool. Yeah. Our tool work really well. We have had a lot of good results that we measure. So yeah, we wrote a paper about that. If you're interested, I can send you the title of the paper. Yep. So these first class IDE events that the tool records that we use for to facilitate commits, we would like also to use them to do code review. So typically, code review tools, they let developers review based on lines. So the reviewers will say, oh, this line has been removed, this line has been added, I would like to put a command there. We believe this is not the right level. We believe the developers should be able to comment on a refactoring. The developer should be able to say, I don't really agree about this rename, and point to the rename itself, not about the line that removed the definition of the methods that has been renamed. We also would like to use that to analyze the behavior of developers. So yesterday, John Brown talked about refactorings. So one thing we could do is to analyze developers' behavior to see how developers use refactorings, or how they don't use them, and why they don't use them, and what they do manually that we could do automatically. We would also like to use this tool to help evolving dependencies. So you are a developer of a library, you work on your library, you fix things, you add new features, you deprecate stuff. The idea here is that we would have a tool that records everything that you do as a library developer. And this recording, we believe, could help the developers that use your libraries. So if they have all the information, if they know exactly how you changed the library, maybe this will help the developers adapt to the changes in the library. So there is a lot of things about that we would like to do. Any question? So the tool that I showed in the previous slide is divided into two things. The first one is Epicere. So Epicere is the tool that records all the changes that you do. And this one is going to be integrated this week or the next into Pharo 5. So if you are already using Pharo 5, then you will get Epicere very soon. And the idea here is that we will remove all the previous tools that deal with version history of method that let developers recover lost changes. All the previous tools that were using the .changes file, they will migrate slowly to Epicere because the infrastructure is much nicer. The tool that creates separate commits, currently it's not included into Pharo because it uses machine learning algorithm, and the machine learning algorithm is not implemented in Pharo but in Python. So we don't really know what to do. Nobody is expert in machine learning algorithms, so nobody stepped up to implement the algorithm that we used in Pharo. The only feedback that we got from people who know is that this might be difficult. So we didn't do it yet. So this untangler stuff will be in Pharo as soon as we have the algorithm implemented. Any other question? Sure. Okay. So I would like to talk about something that I really like. So the previous one I also really liked, but this one I like a lot. So the idea here is to facilitate the implementation of constructors. So constructors, they let a class specify how its instances can be built. So in Smalltalk, we have instance creation methods. So here is an example of a class that has 16 instance creation methods. The idea of this class is that it's a text area that has a certain number of rows, a certain number of columns, default text and scroll bars, and all of these fields have a default value. So if you want scroll bars, you can specify that you want them, but by default there is none. If you want to specify that you want 10 rows, then you can do it, but if you don't, then you will get 5 rows by default, stuff like that. So as a as a class user, you might need one of these 16 constructors because some values you would like to specify and some values you would like to keep to the defaults. The problem is that for the class developers, this is a lot of work and a lot of maintenance efforts. And if tomorrow the developer of this class wants to add a new field that may or may not be initialized, you have to multiply everything by 2. So it's not 16, it's 34, right? 15? Yeah. So if you have n fields which may or may not be initialized, you get 2 per n constructors. This is way too much work. So typically developers don't do that because they are too lazy. They just pick a subset that they think might be the subset that will be the most used, and then the class users will have to deal with this subset. So it means that the developers will have to use something that's more complex than what they would like to use. So we believe that this is not acceptable. So here you have an example of a point class with x and y fields that you would like to initialize to values. So here the class designer specified an instance creation method with 2 integers. So this is standard Smalltalk to create a new instance and sets fields. As you can see here, the methods x and y are used as mutators of the instance variables because from the class side there is no way to modify the instance variables. So as a class designer, you have to add mutator methods on the instance side to be able to specify the states from the class side. So this is one way to do it, and this is typically what the Smalltalk developers would write instead. But this is exactly the same problem. So we send x and y to the new object and to be able to set the fields. The problem here is that as a class designer, if you want your point object to be immutable, you still have to provide these mutator methods. This makes no sense. Why should you add mutating methods and pollute the class API with methods that you don't want the developers to use? Now let's imagine that you have another way to initialize x and y. For example, using polar coordinates with rho and theta. And imagine you have a subclass colored points that wants to keep the two possibilities to initialize the position, but also wants to add ways to specify a color. So here, as a user of the color point class, you would like to initialize the position using either Cartesian or polar coordinates, and you would like to instantiate, to specify the color by using either RGB or HSV. Those are two different color palettes. The problem here is that as the class designer of the subclass, you have to duplicate all the constructors of your superclass to add initialization of the new fields. Again, we believe that this is not acceptable. So what we propose instead is to make initialization modular. So the idea here is that each way to initialize a field or a set of fields should be written once and only once. So if you want to initialize x and y by giving the possibility for the developer, for the class user to specify values for each of the instance variable, you would write something like that. So you ask the class points to add an ini module where x and y should be given by the class user. And so this is what I call the input. So this is the input of the ini module, and this is the output of the ini module. So the output here is empty. We only have inputs, and from this input, we want to modify the instance variables. So the code to modify the instance variables based on the x and y inputs is like that. So here we have a dictionary int vars that we need to set to specify which value goes into which instance variable. So again here, by writing that, the developer specifies that x and y are the inputs of its new ini module. Int var is a dictionary that the framework provides that the developer has to use to put inputs inside instance variable. So okay. Just like that, this doesn't look too important, too nice. But this is now what you would do if you would like to initialize with polar coordinates. So here the developer specified that if you give me rho and theta as inputs, I will produce x and y. So here I'm not setting any instance variable, I'm producing output that another ini module will consume. So here you see that the message here is different. So this one was add ini module with code, and this one is add ini module with output. So here the ini module looks like that. So it's still a block. The first two values are still the inputs. There is no inst var here because we are not going to modify an instance variable. We are instead going to output values, and we are going to output x and y values based on some computation. So how does it work in practice for the class user? The class user would write something like that. So the class that he wants to instantiate, instead of calling new, he would call meet new by sending a dictionary where each key is one of the input variables of the ini modules, and then the values are the values for each of these keys. So how does it work in practice? In practice, when mipnew is executed, the ini modules will be ordered in some particular order. I won't enter into the details. It's in the paper if you're interested. And if you have questions, you can always ask. So here, this ini module will be executed. Rho and theta will be eaten from the collection. This code is going to be executed to produce x and y. X and y will be added to this collection. Then this ini module will be executed. X and y will be eaten and passed as parameter to this block, and then the instance variables x and y will be initialized. Yep, please.
I think that is less code than the previous.
Yeah, so I agree with you. Currently, it doesn't look sexy. Currently, this doesn't look sexy. So the next slide will show you why this is sexy.
What about the cost from creating the objects you are creating a collection?
Yeah, so in fact, we have started benchmarking our algorithm, and this is bad. Really, really bad. You don't want to use that. But we have plenty of ideas to make this really fast. So one way is that we would like to encourage developers to write literals everywhere. So here you see that I didn't write dictionary new add, but I used a literal array, and the same thing here. Here this is literal. The idea of that is that we have two benefits by using literals. The first one is that we can write tools that will analyze the literals to make sure that at compilation time there won't be problems. So at compilation time we will make checks to be sure that at execution time there won't be problems. So for example here, if you only specify theta at execution, you will get a problem because you need both. So we want to write tools that will make sure that both are specified. So this is one of the benefits. It's a write tool, and another benefit is for performance. So if when we compile we know a lot of information about the ini modules and how they are used, then we can cache a lot of things, and we can generate methods that instead of the mipnew being generic for all the classes of the system, it can be very specific to the list of ini modules for one particular class. So we have a lot of ideas like that to make things fast. But currently this is really very slow. Okay? Any other question? So you want to see why this is sexy? Yes? So currently nothing is cached, everything is slow, and I agree that we will probably need tooling for refactoring the ini module and ini module users. I agree with you, but currently this is very early work. We made it work, So that's the first step. And then the next step is to make it nice. And also we are wondering how we can show this, because currently those are objects. So you send a message to a point with a block inside, and this disappeared. So this is stored somewhere, but the developer has no clue. So we want to work on tools to let developers write this and modify them easily. Yeah. This is another work, and this is something that we would like to do, but this is totally unrelated. And here we fix not only the subclass. Here we fix not only the pollution problem, but also the duplication of code and duplication of information and stuff like that. Yeah. Okay, so I continue, and then we can go back to your question if you want. Okay. Any other question? Yeah. So there are ways. So you can write code and put it there. You can write code and put it there, and here you can write code and put it there. So you can have behavior here, if you want, and I will show that in the next slide. But here, there is some behavior here, but I agree that we might want other things. So let me show you the next slide. Now for the color points. So this is where the approach starts to be shiny, because in the colored point class, I know that all the position has been already handled by the superclass. So when I design the subclass, I don't care anymore about the position. I want to forget that this is handled by the superclass. This is its responsibility and not mine. So all the stuff about x, y, rho, theta, and coordinates, I don't care. When I'm writing the colored point class, I'm interested into color, because this is what is the difference with my superclass. So I just need to add a new any module that takes RGB as input and produce nothing as output, and sets the instance variables based on these values. And now for the HSV color palette. This is what you would write. So you take HSV as input, you generate RGB as output, and you generate a literal array with RGB where you extract R from HSV and the other stuff. And the formulas are a bit complex, so they are in separated methods. So as you can see here in the subclass, I don't care about position anymore. I don't care about x, y, rho, and theta. And this is where the approach is really nice, because now I can add a new, for example, complex coordinates to my superclass without doing anything at the level of the subclass. So the responsibilities are clearly separated now. And this is how you would use that. So again, color point, mip new, and then you pass the attributes that you want to initialize. So here we would like to initialize with polar coordinates and with HSV color palette. Here the order of the elements in the dictionary is totally irrelevant. So you could have written hash, theta, rho, s, v, it works. We don't care about the order. So how does that work? When this is executed, the ini modules are ordered. And then the first one is executed. So we are looking for HSV. So is HSV in the dictionary? Yes. So the algorithm eats HSV. it computes the corresponding RGB, and it adds RGB to the collection. Then this one is executed, RGB are eaten, nothing is produced. And now the collection only contains rho and theta. And then rho and theta are consumed, x and y are produced, x and y are consumed, nothing is produced, and all the instance variables have been initialized. So with this approach, we converted from this, where you clearly see that x, y, rho, and theta are also part of the subclass, and this subclass requires four instance creation methods, and here we only have two, and both are very, very simple, and we don't care about the values of the superclass anymore. And if you want another color palette, instead of adding two more constructors on the left, you can only add one conversion ini module on the right. If we go back to the text area example, we add 16 constructors on the left, and now we only need 8 ini modules on the right. And if we add one more field on the left, we need to multiply this by 2. This is 34, and here we only need to add 2 ini modules. So this is much, much simpler. And what's nice also is that all these ini modules are very, very simple. So this one specifying that if you give me rows, I will put that inside an instance variable, looks like that. So you take rows as inputs, and you put that inside the rows instance variable. So all the ini modules on the left of the text area class looks like that. So very simple, and we would also like maybe to generate this from a high-level description because they are so simple. We could generate them. And on the right, all the ini modules, they take nothing as input, and they produce default values as output. So here, if you give me nothing, I produce rows where the default value will be 5. So this is how you write default values. Again, this could be generated from high-level description. This is how you would initialize and text area methods. So with that, we have the benefits of having 16 constructors, but the class developer doesn't have to implement all of them. Any question about that before yeah? Breaks, the. Okay. Yep. For me, this is not the big problem. If you are interested in having names, you can always add instance creation methods with this particular name. If you are interested in that, you lose the fact that you don't need to implement them, but you still have the fact that you don't pollute the API of the instance side. So if you want, then you can. Yeah. I think that from what I've seen of Smalltalk code, the instance creation methods, typically their names do not convey too much meaning. So typically for a person it would be new, named, aged, and birthplace. This does not make more sense than something like that, in my opinion. Yeah.
Yeah, I think maybe your examples are using really bad design classes. I mean, text area with all those variables, clearly a smell of bad design. Also, color point, students in class point, have an instance variable point and another one that is color. And if you do that, you wouldn't have that initialization problem that you are showing in this example.
Yeah,
so,
I totally agree.
So my question is, if you do it right, would you need it?
I think that this is not so binary. So there are plenty of cases where you have more than one instance variables, and sometimes you cannot just create an object. So what you are proposing is to, for example, for the colored points, here you would say that a colored point has an instance variable color and instance variable point, and to initialize a colored point, you need to pass a color and a point. Yes, but yeah, why not? But then you put the burden on the user to instantiate each of the parameter. Yeah, and maybe as a class designer, this is not what you want. Maybe you would like to tell your user, oh, maybe use this method because they are simple to use. If you want to give me a color, then yes. So a color could be another way to initialize a colored point. I agree. But as a class designer, you should not constrain too much your user to instantiate objects that they don't really need. They need to set...
Think about that you're creating a language. But that's what you do when you're programming. So you're composing, the words that you're creating. So it makes completely sense. Just give me the point, give me the color. That's the color. So, I don't know.
Yeah, no, I agree, and sometimes I would like to say that no, this is not how I want to design my class. But I agree with you that in many cases, doing that would solve most problems. Not all of them, but most problems. So, for example, you would not solve the API pollution problem.
What?
The API pollution problem, the fact that on the instance side you have to add mutating methods.
No, because you only have one private method. Initialize with point, with color, and it's a private.
Yeah, it's convention, I agree. But you still pollute the interface. I agree. But, yeah. Any other question? Yeah.
Maybe I'm missing something very important, but I still don't see what's the difference of using this and the concept which is used for years in Python and in Ruby, which is called these keyword algorithms. Basically, they pass a dictionary, like a key value to a method, and the method kind of picks stuff that it needs from the dictionary. They have a syntax support for that to some extent, but to me it looks pretty much the same.
Yeah, so the default values, for example. So this is something that we would like as well in Faro, to be able to specify that a method for this parameter, if you don't specify it, its default value is 10, for example.
Yeah, but this is the common pattern, right? Because if you get the dictionary of the values, then you pick the value which is in the dictionary or something from
No, I agree. Yeah, so no, we would like that not only for construction but for all methods. For all methods, we would like to specify sometimes that a subset of the parameters and getting the rest use default values. I agree. But you would not solve all the problem as well.
So there is no difference there, or not so different?
No, the difference is that with the... let me think. So this is in the paper, but I forgot the particular example. Yeah. We can talk again. I agree with you, and this bothered me also at the beginning, but we found a lot of cases where having default parameters for methods would not solve the problem. No, it's just that I forgot them, but yeah, it might just be because I'm here talking to you and not in front of my computer thinking. Okay? So I have 5 minutes left, right?
No, it's done.
It's done.
But if you have something else to say.
Yeah, so very, very fast. So an overview, I wanted to talk about some development projects. So very fast, Pillar is a tool that takes some text as input and produces output in many different formats. We use that for writing the new books. We did that because before we were writing books in LaTeX, and the community did not participate because LaTeX is hard to install, is hard to use, is hard to learn. Pillar is much, much simpler. In fact, we extracted the wiki syntax out of Pillar, and we created Pillar with that. The new Faro by example book that's updated to the latest version of Faro uses Pillar, and also the new book Enterprise Faro uses Pillar. We can generate slides with Pillar, so those nice slides with columns, itemized figures, stuff like that, they are generated using Pillar. We can also generate websites with Pillar. And I wanted to send a message to the students, to the teachers, and to the developers with a bit of free time. We need people to work on this tool. There are more and more users of this tool, and unfortunately I don't have so much time to maintain it, to add features and clean it. So if you are a student and looking for a project, or if you are a teacher, or if you are a developer, then please come and help. The Faro launcher is the tool that I wrote. I showed you quickly how it looked like. So the idea here is that you should manage your images easily. On the right, you have a lot of places on the web where you can download images from, and on the left, you have your local images. So the idea is that you double-click on something on the right, it downloads, it unzips the zip file, and it renames the file, and it appears on the left, and then you can double-click to launch. You can also rename, copy, duplicate, do whatever you want. So this is very, very easy tool to manage your Faro images. This is a new design of the Faro launcher that I created, but I need you to implement it. And the idea is that this tool will be the next default download. When you click on the big download button on the Faro website, you should get this tool, but I have to do some things before it becomes a default download, and I don't have time. So if you want to help on this, then you're mostly welcome. The Faro MOOC is a huge project. So we are creating a lot of lectures, slides, exercises, tutorials, a lot of things. Free and open source, accessible to everyone, so that people can learn Faro, can learn object-oriented programming, can learn object-oriented design. We are getting filmed on January, and on April or May, the MOOC will be available for everybody. It's already on GitHub. But yeah, everything is done in Pillar. So all the exercises, the slides, everything is done in Pillar. Remote development, this is a project that started very recently because it was yesterday evening. The idea here is that Faro already can control Gemstone, so you can write Gemstone code inside Faro. And Dale implemented all the infrastructure to control Gemstone for Faro. But we would like to reuse this infrastructure in other places. So we would like to reuse this infrastructure to control Gemstone from the command line, to control Gemstone from Eclipse, to control the Gemstone from Emacs, and also we would like to do the same with Faro. So we would like that from Faro we can control Faro, then from Emacs we can control Faro and Gemstone, stuff like that. So again, yeah, I have plenty of projects like that where I need people. So yeah, don't hesitate to come. Hermod team is recruiting, so we need one PhD student working on programming languages, one young engineer working for the Faro consortium to develop on Faro, and we also recruit a lot of interns. So if you are interested, then just contact Stefan Dukas. And this concludes my talk. Thank you very much.